Hello there. In the previous video, we went through Boyle's law, and we did a first example in terms of just how to use Boyle's law. In this example here, it's going to be a little bit more complicated. There's going to be an extra step that we have to deal with. So for example 2, let's say pressure, our starting pressure, is 0.976 atmospheres, or ATM. Volume, instead of liters, let's say it's 35 milliliters. Let's say P2, our new pressure, is 52 kPa. So what we want to find out is the new volume, okay, V2. But we don't want it in milliliters, we want it in liters. So the fundamentals are the same. You're still going to use Boyle's law, which is P1 V1 equals P2 V2. The difference is you have different units for pressure. Because they're different units, we can't put them in mathematically and expect to get a reasonable answer. Okay? We have to make sure that the units are the same. So first step is convert units. Okay? You do this if it's necessary. So in our case here, 1 ATM is exactly the same thing as saying that we have 101.3 kPa. And I've mentioned this in a previous video yesterday about this relationship. Okay? And there is another unit that all these are equal to, but these are what we call normal pressures, okay? Our standard pressures. 1 ATM is 101.3 kPa. This is actually our conversion factor. Okay? So it doesn't matter which one we take. Let's pick 0.976 ATM, and let's say we want to convert that into kPa. So using our conversion factor, we want to get rid of ATM, so ATM goes on the denominator, and 101.3 kPa is up in the numerator. So these two cancels out, and you get 98.87 kPa. Okay. The alternative is to take this 52 ATM, okay, and maybe convert that. 52 kPa, and convert that to ATM. Okay. So again, our conversion factor puts 101.3 kPa down the bottom and 1 ATM at the top. kPa cancels out. 52 times 1 divided by 101.3 gives us approximately 0.51 ATM. Okay, so we need to have values in the same unit before we can use Boyle's law. So 2 is just rearrange your formula so that it's set up to find what we're looking for. So in this case, in order to find V2, we have to take P1 V1 divided by P2. Okay? So that's going to equal, and again, it doesn't matter which one I use. Let's use the ATM. So let's say 0.976 ATM, which is the original number that we have, times 35 milliliters over our newly converted ATM. Okay, so that's 0.51 ATM. So when we cancel out the units of ATM, our V2 comes out to be 66.98 milliliters. Okay, and because it's in milliliters and we wanted liters up here, we're going to have to convert this. Okay, so two easy ways. You can move the decimal place 3 places over, okay, which is basically dividing by 1,000 to convert from milliliters to liters. So this is actually going to end up being 0.06698 liters. But again, we want 2 decimal places. So that, when we round off, it gives us 0.07 liters. And that would be your final answer for this one. Okay. I kind of mentioned before that there is another unit. So if you haven't finished writing everything, you can just pause it and let yourself catch up. But for example 3, if I have 3.5 ATM, let's say V1 is 100 milliliters and V2 is 500 milliliters, and I want to know what P2 is in something called millimeters of mercury, okay, which is another unit for pressure. I need to know what the conversion factor is, okay? And the conversion factor for ATM to millimeters of mercury is actually 760 millimeters of mercury. And this is an old-fashioned unit, but it does pop up once in a while, so it's good to know how to convert. So we're going to take 3.5 ATM times the conversion factor. And that will give us a large number, 2,660 millimeters of mercury. And it's common for the numbers to be big if it's based in that unit. So once we've converted our units, we rearrange our formula. So now we're finding P2, and P2 is basically P1 V1 divided by V2. Okay, and if we put everything in, it's 2,660 millimeters of mercury times 100 milliliters of gas over 500 milliliters of gas. Okay, the milliliters will cancel out, and all that will remain is millimeters of mercury. So P2 in this case ends up being 532 millimeters of mercury. Okay, so we can kind of expect this, because if you look at our volume, our final volume has increased from 100 to 500. So if there's an increase in volume, the pressure has to decrease. Okay, so the pressure started off at 2,660 millimeters of mercury, and now it's decreased to 532 millimeters of mercury. So whatever you do, okay, you can always double check with logic to see whether or not this number is correct or not. Okay, if it's much bigger than what you had originally, there's probably a math error somewhere. Okay, so these are pretty straightforward. I want you to try out assignment number 1, which is based on Boyle's law. And if you have any problems, feel free to just email me, okay, or rewatch some of the videos.